So, hello everyone. In this video, we are going to the quick revision what we have done on other classes on coordination compounds like valence bond theory. We have discussed about the geometry and the magnetic behavior of different complexes. So, I have taken many complexes for you for you to understand now. Okay, so that in exams you don't face any problems. So we can solve this very easily. Okay, so I will explain this with many examples. So we'll do a quick revision. Okay, so we know. Okay, then see here there when there is a strong field ligand, okay, that times what happens, the electron pairs up. Okay, and when there is weak field ligand, then the electron does not pair up. So these ligands are your nitrogen, phosphorus, and carbon. When these are your donor, that time what happens, it is a strong field ligand. For example, cyanide, NCS, then phosphorus, then you have carbon monoxide, ammonia. These are all your strong field ligand. Whereas if when you go for weak field ligand, then sulfur, oxygen, and halogen, these are your donor atoms. For ammonia and water, there is some exceptions that they don't act, they sometimes act as you can say strong field ligand, and sometimes act as weak field ligand, only depending on some characteristic we'll discuss in the other class. So by following these character symptoms, we are going to start with your n complex. See here, this is your nickel 2 plus. Okay, that means D8. How many electrons are there in the orbital? That is 8 electrons are there. So chlorine, we know chlorine, how chlorine is a weak field ligand. Okay, so what will it do? Will it take the inner d2 orbitals? No, it won't take your inner d2 orbitals. We can draw this orbitals, or we can directly write the shape. It will be your sp3. Configuration will be sp3. That means your hybridized orbital will be your 4s and 4p. Okay, so sp3, so it is becoming NiCl4. So geometry will be your tetrahedral. And your magnetic behavior, because nickel 2 plus, so there will be you can say electrons will be there which are not paired, so it is paramagnetic in nature. Paramagnetic in nature. Okay, so this class will be understood by only those students who have done my previous videos, who have studied the previous videos. Okay, so if I do only the d orbitals, so it is 1 2 3 1 2 3 4 5 6 7 and 8. So two unpaired electrons are there, so it is your paramagnetic. Now see cyanide. Now cyanide is a strong field ligand, so what will happen, these electrons, unpaired electrons, will pair up. Okay, so your structure will be how many molecule of cyanide? That is 4 molecule, so it will be your dsp2. So it will be your square planar. Okay, and now all the electrons are paired, and hence it will be diamagnetic. Now see here, nickel carbonyl. So carbonyl here it is 0. Okay, so your oxidation state of nickel here is your D8s2. Okay, so how many electrons are there in the d orbitals? 1 2 3 4 5 6 7 and 8. And there is another 4s orbital also. So what happens, these electrons, it will, nickel, since it is carbonyl, it is a strong field ligand, and it will tell the electrons to pair up. This is your 3d and this is your 4s. Okay, now in this case what happens is that, see here, these, how many electrons? 1 2 3 4 5 6 7 8 9 10, total 10 electrons. So if I fill these means, since carbon monoxide is a strong ligand, so what will happen, it will pair up. So if it pair up, that means all the three or d subshells will be filled. Okay, so we are going to left with your 4s orbital and your 4p orbital next. Okay, so how many carbonyl? 4. So it is your sp3, hence it is your tetrahedral. Okay, so and there all the all the electrons are paired, and hence it is diamagnetic. Now we'll go for Mn2 plus. Mn2 plus is D5. What is the configuration? It is your D5. Mn2 plus 5. Now cyanide is your 6. Okay, so it will form your, see, hence it is cyanide, so it will try to pair up, means it is a strong field ligand, so it will tell these electrons to pair up. So what will happen, so if it is pairing up 1 2 3 4 5, so what will happen to these electrons, it will pair up. So 1 2 3 4 5, so these it is going to be adjusted out here, so two d orbitals are left now, so it will form your d2sp3, and so d2sp3 is nothing but octahedral. This is your inner orbital complex. Okay, so now only one electrons there which is unpaired, so it will be your paramagnetic. Hmm. Now see here MnCl4. Again see here, because chlorine is a weak field ligand, so all D4 3D subshells are filled, so it will not pair up. So what will happen? So four electrons are there, so s orbital is left out and p. Next 4s and 4p it will take up, so it is going to form your sp3, because 4 chlorine, so 3 of period is your sp3. So what it will be? It will be your tetrahedral. Okay, so unpaired electrons are there, paramagnetic. So here we are coming to your copper 2 plus. What it is? It is D9. So how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, and your 9. So it has only one unpaired electron in the 3D subshell, and there is 4s and 4p. Now see, it is chlorine. It is a weak field ligand. Okay, so it is going to form your sp3 hybridization, and again it is tetrahedral. Okay, so one unpaired electrons, paramagnetic. Hmm. Now see, ammonia in this case is your strong field ligand. So what will it do? It will tell all the electrons to be paired, but it is almost paired. Only one unpaired electron is left. So it will shift this one unpaired electron to the other 4D orbital, and so now it is going to form your dsp3. So dsp2 it will form, and it will shift one electron. Will shift this electron to the p orbital, and it will take one d inner d orbital. So it is forming inner d orbital. So it is dsp2, and it is your square planar. It has one electron which is unpaired, so it is paramagnetic. Okay, so now chromium 3 plus. Now see chromium 3 plus ammonia, since it is your strong field ligand, we know. So what will it do? It will try to pair up. But here see, because it has already two d orbitals are emptied out there, so it is not willing to pair up. It just takes your d orbital. So it takes your d2, your sp3, because six ammonia molecules. So it is d2 sp3. Again, see, it is your octahedral, and then this is again your inner orbital complex, and this is paramagnetic. In this case, even with chromium with water molecule also, if it is 3 plus, same. See here, it is only 3 electrons only, so even if it is it does not pair, it doesn't there is no matter. So again it forms your d2 sp3, which is again your octahedral, and this is your inner orbital complex. Okay, and this is again paramagnetic. Now cobalt 3 plus, and that is your d6. So here how many electrons in the d orbital left? 3, 4, 5, and 6. Okay, so now see, ammonia is a strong field ligand. So what it will do, it will tell all the electrons to pair up. So how many electrons? 6. So 1, 2, 3, 4, 5, 6. So again 2 orbitals becomes empty this time, so it becomes your d2 sp3. So it is octahedral again. Again, this is your inner orbital complex. This is now diamagnetic. No unpaired electron. Okay, same in this case of fluorine. Okay, F6, because fluorine is, again, we know it's a weak field ligand. So what we will do, again, it won't pair up. It will be like this only. Okay, so it won't pair up. It will take your sp3d2. So this is also your octahedral, and it is again outer orbital complex, because it is taking sp3. So 3 4 files it is taking from sp3, it is taking your outer d, so it is your sp3d2, and it is your outer orbital complex. It is octahedral only, and it is paramagnetic. Okay, so this way we have done these molecules. Let us go to some more molecules. Here also we will take the same formula of strong field ligand and weak field ligand. We'll put that. So see here, cobalt d7. 1, 2, 3, 4, 5, and 6. 6. Now see, this is water molecule. It is a weak field ligand. So how many water molecules? 6. So hence it will take your sp3d2 outer orbital complex. So its geometry will be your octahedral. This is taking your outer orbital complex, and the behavior is paramagnetic. Okay, now iron, now this is iron 2 plus, so it is D6. How many? 1, 2, 3, 4, 5, and 6 in the 3D orbitals. Okay, so cyanide is a strong field ligand, so it will pair up. Okay, so how many? 6 electrons, so 1, 2, 3, 4, 5, 6. So 2 orbitals are now left, so it will form your D2sp3 octahedral. This is your inner orbital complex now, and it forms your diamagnetic. Why? Because all the electrons are now paired. In case of your water molecule, it is again weak field ligand, so these electrons will not pair up. So it will form your sp3d2. So it will take the outer d orbital, so it will form again octahedral, but it is your outer orbital complex. And it is outer orbital complex, and this is your paramagnetic. Okay. Now this again here ammonia NH3 D2sp3. Again it is your octahedral. This is your inner orbital complex, diamagnetic. Fe3 plus. Now this one, see how many electrons are D5. Okay, so D5, now see here again Fe3 plus, so 6 cyanide molecules. So it will cyanide is a strong ligand, it will tell it the electrons to pair up. So it will be again your D2 sp3. So last 2d orbital will be empty, so it is your octahedral, and this is your inner. And now what it becomes, it is paramagnetic. Why? One paired unpaired electron is there. Okay, now see in the last case, that is your FeCO whole 5, where you can say this carbon CO carbonyl, it is 0, you know, so it is D6 and S2. So there is again 4 s orbital also, like this, 4, 5, and 6. Okay, now how many carbon is a strong field ligand, so it will tell all the electrons to pair up. So it will, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So total 4 orbitals of the d orbitals are filled. Now only one is left, that is your 4, 5. Okay, so what it will be, this is your trigonal bipyramidal. It is DSP2. Sorry, DSP3. So it is trigonal bipyramidal, and it is your inner orbital complex because it is taking inner D. Okay, so now we are done with all the examples which are there in textbook, or you can say in our reference. So basically I am done with this the chapter of valence bond theory. So if you have any doubt, do ask me in the comments. I will try to take up some questions more, and I will go to the next. We will go for your crystal field theory. Thank you.